Well, hello, everybody. How are we today? Good morning. I am going to start the stream by eating lunch. Interesting. It never auto refreshed on my copy of it. Um. So, this is what we left off with. I made these notes about what I wanted to do. And last night I did a little Googling because I want to generate pseudo-random noise streams, but pseudo-random data streams. And so I finally read the PCG paper, or enough of it to decide that, yeah, it's a reasonable thing and implement that. Because so all modern random number generators are 64-bit, and since this is BC6 is 32-bit, I needed to use something older. And PCG has a 32-bit seed, 32-bit result function. It supports multiple streams that are guaranteed to be different by using a different value here. But I'm comfortable with, if you happen to fall into the same stream, you'll get the same data. Because of the way we merge corners, edges, and the main block. If two corners happen to randomly generate the same thing in different places on the map, those corners themselves will be the same, but all the edges and adjacent data won't be. And similarly, if two edges happen to get into the same random stream, they'll have different adjacent corners and actually do different things anyway. So the only way this would be visible is on corners. So the PCG paper was like 10, 12 years ago. It was never published in a journal for various reasons, but it looks legit. And it's just based on the observation that most pseudo-random number generators either have a complex update function and then use that value directly as the random number, like a classic LCG, or they have a simple update function like incrementing, and then they mix the bits really well, like with a crypto primitive. And PCG invented a new shuffling method for the output, which we see here. Combine that with a multiply that's to shuffle even further. Basically, the uses an LCG on the internal state. The LCG tends to mix the top bits really well, so you shift those right and XOR them to get them mixed down a little bit better. Then multiplying by something mixes the high bits again. And then you mix into the low bit, those high bits into the low bits. So it all actually makes sense, these magic numbers. And there was somebody who did an analysis of PRNGs for GPUs, which tend to be 32-bit, and looked at PCG and said, did a Pareto frontier of all the best ones, and PCG was way better. It was on the Pareto frontier, but it was also like just way higher quality for the speed than anything else in the vicinity. The only thing faster was one by IQ, but it was probably the sine function thing or whatever that makes sense on GPU but doesn't make sense on CPU. So you update the state and then you shuffle it, and that's the result. And in this code, we actually shuffle the old state and update to a new state, and that just lets this code start running without a dependency on this, so it reduces the critical path. Everything here where we say road corner, road edge, crossing, road is actually short for road network. So it's a road network corner, a road network edge. And really it's a road network chunk corner, a road network chunk edge. But it doesn't make sense to type that all out. But we do want to make this change. Currently 512, and I'm pulling the trigger on increasing it. Have to scale down our debugging. We've done something wrong. These are not scaled at 1024. So somebody's still multiplying by 512 in here somewhere. We're not drawing those correctly. We're not drawing them on the other sides. Somebody is clipping wrong, probably. closer to correct, but we're still not drawing that edge. We did here, but didn't here. Seem to have hit all of the 511s and 512s. Are we still drawing those clipped roads? Yeah, we are. A clipped road. Oh, it was just because it was too thin. It was less than 1 pixel wide, so it was dropping out. So compared to where we are before, this is much more only constraining the edges. The edges intruded pretty far in when it was 512. Why are they so evenly spaced? These. I guess that's why we want to do different logic. Well, they're evenly spaced because I evenly space them plus or minus a little bit. Okay, now they're not evenly spaced. Yeah, here's some very uneven spacing. I don't think that's... So if we want to actually hard constrain these lot sizes, I don't know. I don't know how to do this. Because this, we're constraining it, but then renormalizing again right here. Because it needs to add up to the total, so... Gosh, this is so finicky. I guess that was the experience I had the other time too. All right, well, let's apply the logic from this to do. So we want to compute it's the corner side dist again. But now I guess this is I got to close that window. And then can be facing in it's actually kind of big, the minimum, but we'll just set it to that for now. Let's say that. Okay, that's fine then. Of j of I equals corner side just j of I absolute greater than min facing just let's just check less than. Let's assume that's always true. That replaces this logic. Okay, so now that is this. Check that off. There's a fourth variant. If so, I'm so sorry about this creaky arm. So, variant number 1 is allowed. It's done by allow simple connection. Okay, variant number 2. Let's call that tangent connection because it's going through tangent on both sides. Well, call it a direct connection. A tangent connection. Then what we have to do is check where that falls in the other one. If outs of CSD minus corner side dist bang j of 0 int bang is a little weird. Let's make it 1 minus. So if it's far enough away from both of those, so let's add a int min intersection spacing. So the distance from the center to the center of two things. So assume the widest thing is going to get is 32. So intersection spacing of 33. If this one is greater than min intersection spacing, and this 2 is greater than min intersection spacing. Then allow a tangent connection, which it connects on one side. Now, right now, we'll accept whichever one comes last. So if both of them are possible, but both of them should never be possible, I believe. Well, no, that's not true. They can both be possible. So, if allow tangent connection has already been seen, and randomly 50% of the time, then skip this. Because I believe it will only, you can only have at most 2 of them, even though the code iterates through 4 cases. Let's go ahead and fill these out. Variant number 3, allow simple connection. Allow direct connection. Tangent connection. Simple connection, direct connection, tangent connection. Maybe we try 8 simples. It doesn't actually need a boolean, therefore. So simple candidates. Okay, so that's in simple. Let's do this. M equals K plus K greater than simple candidates or 2, 1 colon 0. So M goes 0, 1, 2, 3, 5, 6, 7, 8. So then we do M equals linear remap from M 0 to simple candidates what was it? Min facing distance, max facing distance. So from negative max facing dist to max facing dist. But actually, let's move it back from the edge there by going to those. I guess we can do more simply. Instead of this confusing math. is just let it compute 0. This will include 0 in the output. If absolute m is less than min facing dist. Okay, so by default, we'll set a simple connection to 0. That means it's disabled. If it's too close to the facing distance, then we don't continue operating. If corner side dist of j of I m minus that absolute is less than min intersection spacing, then we have to fail this one. Let's do it this way. Makes it easier. Okay, so now we have 3 simple methods that just draw a line across the whole thing. Well, I think we do want this allow simple connection. Check under the video for the FAQ. Do we really want to just throw out all this code? I think we do. So, if allow simple connection, CB shuffle, simple connection, candidates, simple connection, compare 0 byte offset. Then if simple connection of I is not 0, side dist equals simple connection of I work. Okay, so at this point we've computed side dist if there's a simple connection, so then we say if allow tangent connection, so I want to make sure tangent connection doesn't replicate. Yeah, it doesn't. Okay. If we allow tangent connection, then if side dist equals 0, or we want to do a random number. So let's start switching over to the new random number thing. So let's just do 2. Might only really want to do 1, but we'll do 2 for now. I don't see us using it anywhere. It's not till further down, I guess, that we use it. Yeah, okay, here. It's RR. Oh, yeah, let's just do 1. We'll just embrace it. Embrace the new. Yeah, RR mask is RRM. So this should use an RRM. Except, yeah, this probably just doesn't even make sense anymore. So if we don't have a side dist yet, or if RRM 50%, and side dist equals tangent connection. These should be dists, I think. If allow direct connection, side dist equals 0. Okay, then this first one is the far side, the near side. would just always use the side disk now. This one does need to get updated with don't think it matters. Yeah, this doesn't matter because it's about to get overwritten here. RR old. Give this RR. No, we don't have any calls to do it anymore. Oh, I changed the name of that variable. Can be facing dist. Oh, I didn't actually implement linear remap. Thought I did. Didn't I implement linear remap? Maybe it's in a different file. Oh, it's because I use S to be linear remap. Pretty sure that's how you're supposed to use that. Unsigned int differs in levels of interaction from const void star, const void star. Int comp of offset returns a function pointer. So this returns a function pointer. Oh, this has to be shuffle, not qsort. Why am I thinking it was qsort? This just takes a random seed, so we can just use R. And we should shuffle it. So we just get rand. That obviously doesn't work. So this is R mask, R. This is just get rand. R. I'm sure this is broken. So here it found an edge that intersects these two edges without being too close to the intersections on either side. Same thing here. Same thing here. Here it used a tangent or a direct connection. It must be direct. Let's have that affect the width. So width equals 4, width equals 8, width equals 16. No, not when we compute the variance, when we use them. Dun, 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 dun. Equals 8. No, this one is width equals 8. Width equals 16. Width equals 24. Now that, oh, we don't use it anyway. That'll affect the crossing widths here. So these widths should reveal which type of connection it is. I think we gotta make it bigger. So if it's if there's no crossing, do 2, 16, 32, 64. That's comically large, but let's see what it does. We never see 64. These all seem to be the exact same width everywhere. Maybe that data isn't actually getting through. When we draw them, we don't use the actual width. There we go. It's actually using it for the... Oh, because I put it in this one, not that one. Well, that's okay. Okay, now we can put them back to more sane numbers, now that we know what it's doing. So 2, 8, 16, 32, no, 24. It doesn't connect. Why doesn't it connect? Because sub 1, when we draw, when we make the clipped roads, we start at 1, and we do use width starting with 1. But 1 is the one that we build here from Rec 2. And Rec 2 uses side dist. Oh, but we never set width. Okay, so this one is a direct connection. This number and this number happen to be the same, so it could just directly connect a road all the way through. This is a simple connection where it placed two new intersections. Here it failed to find any way to connect them. Here's a tangent connection. So it's tangent to this one, but hits in the middle of this one. So that all seems to be working. There are more variants. Those were the easy variants. Int which facing to if can be facing dist j of I. Which facing of j equals I. The thin, small line in the middle of the longer ones. I'm not sure what you're referring to. In the middle of longer ones. These two seem kind of close. These are roads that cross between road chunks. These included. We're only computing the edges, so the edge decides that there are some roads that cross. But it doesn't know what those roads do further into the chunk. It just knows that they cross. And this is from the old code. We have to update this logic still. Yawning at the 1 hour mark. Let's do something. We're not generating the intersections except here. So let's generate all the intersections. And then where we do the intersection validity, this one, if ri.valid, and let's add it to the intersections. So now we won't get any red intersections, but the question is, do we get every intersection? So we get the intersections of the side roads, and these intersections here. There's no intersections here, that's legit, except that. I don't know why we get that. Because we didn't generate maybe we're supposed to generate a road here. That looks suspiciously like that's supposed to connect to that. Well, we know we need to generate an intersection. Make road intersection XYWH. We know for each corner we need to generate the intersection for it. Make road intersection. Just make all of them and they'll get clipped away. It's so suspicious. It might be that we just have old... I didn't touch the code to generate intersections, so we may just have old code that's generating the intersections incorrectly. And I'm struck by being tired again. Oh. Well, maybe that's just a 1 hour stream. I don't know. We made a little progress getting this new logic in. It may not be worth me fighting it. Yeah, I think I'm going to take a nap break. I only slept for a couple hours last night, so we'll probably continue in a couple hours. But no guarantees. All right. So, thanks everybody. Sorry for the short stream. We will continue when we continue.